Hello everyone. Yes, can you all hear me please? Everyone? Alright, fine. So good afternoon everyone. And we begin with the topic. We are going to continue on this platform only. Let me be very clear because Zoom has got a lot of problems. So that's what I want to clarify. The advantages of taking lectures over here, Mr. Parmar, especially because we have messaged that you want the lectures on Zoom, and that is there are interruptions. The app is not so secure, and 40 minutes interruptions takes place. यहाँ पर ऐसा कोई इंटरप्शन नहीं है. प्लस दूसरा एक एडवांटेज ये भी होता है यहाँ पर ऑन दिस पर्टिकुलर प्लेटफॉर्म कि if you miss out anything, you can once again go back and hear to it. Okay, so if you have not understood anything, or if you missed out anything, okay, it can be done over here. Buffering is there is the not a problem of YouTube. Okay, it is a problem of internet. Okay, तो बफरिंग इज नॉट अ प्रॉब्लम एट ऑल. अगर आप जूम पे जाओगे तो भी बफरिंग होगा, इधर जाओगे तो भी बफरिंग होगा. तो वो आपका इंटरनेट का इश्यू है. ओके, एंड दैट इज गोइंग टू बी फेस्ड थ्रू इन रीसेंट टाइम्स एवरीवेयर. Okay, even those my colleagues who are taking lectures on Zoom, they are also facing the same problem. Okay, तो ये वो इंटरनेट का प्रॉब्लम्स सॉर्ट आउट होने में पता नहीं कितना वक्त लगेगा. ओके, बट एक दो इंपॉर्टेंट एडवांटेज यहाँ पर वही हो रहा है, एंड दैट इज I tried other app also, Nupur, and that is, but then everybody has got some the other limitations. This I felt it was better because this is much more secure because it is of Google network. The second is I can take it for uninterrupted time. Okay, no cancellations in between. Second, you can do a revision also by clicking back on that link. Okay, or you can go to my channel directly because on my channel also it gets posted. So it's a revision type also takes place. Okay, so which is not very possible on the other one. Okay, and other app, if you want to know, I tried for Google Duo is good enough, but then the limitation is there are only maximum 12 participants. Okay, the clarity in Google Duo is very good. Okay, I have taken presentations of my MSc students, but there is a problem, only 12 people can be accommodated. दूसरा है Google Meet, but then once again the problem is of using the camera. Okay, the camera quality is not so good enough. All right, and as a result of which, what I'll be writing on the board, okay, that will not be very clear. And the other problem with Google Meet is that we can only share the PPTs and things like that. If I want to actually teach you, it becomes very difficult. When I do it on the board, it will be very blurred. Okay, when I teach on the board, it will be very blurred, and if I write it down on the paper also, then what happens is, okay, the back camera doesn't work, okay, in Google Meet. So these are the problems which are there. Now you can very frankly tell me what are the problems that you are facing apart from buffering. What are the other problems that you are facing? Please tell me under this. You can just now also I just went through my whatever I've taught, okay, in my previous lecture, and then I confirmed it with Nupur that yes, what is this was being taught about. Okay, so can you please tell me, rather than thinking about searching about for all the other apps, downloading those apps, we are not sure at all about the security of those apps. Please be very clear. Okay, the security of the app is very important, especially in this period. It's a very sensitive period that we are going through. Okay, so we cannot just look into only one part. Okay, that is, yes, this is the particular app. How much is the storage it contains, how much reliable it is, we cannot talk about. Okay, so that's the reason. Roasty pizza, who's that? I've been telling you right from long time that please use your exact name, Roasty pizza. But then with the app which you're talking about, it is taking a lot of data. I can read the comments, and that is more than enough. Okay, Hardik Purohit, you say, sir can't read the comments. But why you are interested in others' comments? Okay, whatever you are writing that I can see and I can address it to you. That's it, no? What others are writing, okay, it's nothing to do with it. Understand, Mr. Purohit? And if you don't understand, you can always put up the comments and I can see it. So I can, once again, go very slowly. Okay, right. So we go into where we stopped last time. Okay, I seen my last time's video, so I came to know that I stopped at the action of halogens with respect to group 16, 17, and 18, and that's what I confirmed also with Nupur. So that is where I stopped. So we go ahead now in this particular chapter, and that is about the action of metals with group number 16, 17, as well as 18. So to begin with, first of all is we start with, as usual, group number 16. And we are going to give only selected examples. Whatever is there in your syllabus, only that much I'm teaching you. Please be very clear. Okay, so to begin with, when you talk about group 16 elements, it's an oxygen family. So action of metals. Come on, please answer me. Is this font good enough for everyone? Can you see it? Hello? Can you hear me, please? Please reply. Is this font good enough? Can you see it? Okay. So we begin with action of metals. So the first one we talk about with respect to group number is 16. So some examples is aluminium. It combines with oxygen. It results in the formation of Al2O3. Then copper combines with sulfur. It gives you copper sulfide. Cadmium combining with selenium. It gives you cadmium selenide. Okay, so all these, okay, that is copper, cadmium, aluminium, they are all going to be metals, and they are going to react with oxygen, sulfur, as well as selenium. Okay, these are group 16 elements. Okay, so this is what we can say, that group 16 elements combines with metals and resulting in the formation of the corresponding compounds. So it depends upon which compounds they are, that predominantly depends upon the group 16 element. Okay, if it is oxygen, it gives you oxide. If it is sulfur, it gives you sulfide. And if it is selenium, it gives you selenide. Okay, so this is selenide. Okay, it is does not depending upon the metal, it depends upon the element of group 16 itself. Now we talk about group 17. The action of metals, where common examples are like sodium combines with chlorine, everybody knows this, it gives you NaCl. I talk about, say, magnesium combining with bromine, Br2, it gives you MgBr2, magnesium bromide. Sodium and magnesium are metals. Once again, as I said, okay, the type of compounds which are formed, that depends upon the group 17 element itself. Now see, the rule is, that is, okay, whenever we go for the nomenclature of the compound, the naming of the compound, generally, एक्सेप्शनल केसेस दोस्तों जरूर होते हैं, लेकिन जनरली ये देखा गया है कि जो कंपाउंड का नामकरण है वो मोर इलेक्ट्रोनेगेटिव एलिमेंट के आधार पर किया जाता है. ओके तो यहां पर ये जो भी एलिमेंट्स की हम लोग बात कर रहे हैं, दे आर मोर इलेक्ट्रोनेगेटिव एज कंपेयर टू द मेटल्स. Group 16 elements as well as group 17 elements, they are more electronegative than the metal with which they are reacting, and therefore the nomenclature will depend upon the element itself. ओके तो जैसे यहां पर मैंने बोला था ऑक्साइड, सल्फाइड, सेलेनाइड, ऐसे यहां पर मैं बोलूंगा क्लोराइड्स, ब्रोमाइड्स, एक्सेट्रा एक्सेट्रा, व्हाटएवर कंपाउंड्स दैट आई गेट. ओके सो ये आपको याद रखना है. नेक्स्ट थिंग इज कि व्हेन यू टॉक अबाउट ग्रुप 17, group 17 elements are generally highly electronegative. Okay, you know this very well. And when group 17 elements are highly electronegative, so in that case, when we talk about, say, a metal, so metal is highly electropositive. And you know very well from your lower classes that when an electropositive element combines with an electronegative element, it results in the formation of an ionic compound. It results in the formation of what? Ionic compound. Because greater the difference in the electronegativity, greater will be the ionic character. Okay, that you need to remember. So when I comparing, suppose if I keep the metal same, say for example, I kept the metal as sodium. Okay, and I'm going to change the halogens. Okay, FCl, I have compounds like sodium fluoride, sodium chloride, sodium bromide, sodium iodide. I got compounds like this. So if I'm going to compare the characters of that, so what I get is nothing but I have MF, I got MCl, I got MBr, and I've got MI. Okay, MF, MCl, MBr, and MI. Okay, these are the compounds which are being formed with the metal being same and the halogens being different. Okay, now you know very well. Metal is fixed, so its electronegativity value is fixed. As we go from fluorine to iodine, the electronegativity value goes on decreasing. So in fluorine, electronegativity value सबसे ज्यादा रहेगा और आयोडीन में इलेक्ट्रोनेगेटिव वैल्यू सबसे कम रहेगा. ये आप मानते हैं सब लोग? मैंने ये ऑलरेडी आपसे डिस्कस कर लिया है. ओके जब मैं इस चैप्टर की प्रॉपर्टीज के बारे में पढ़ा रहा था. ओके तो मुझे बताइए कि फ्लोरीन का इलेक्ट्रोनेगेटिविटी सबसे हाईएस्ट है, आयोडीन का इलेक्ट्रोनेगेटिविटी सबसे कम है. तो इस सिचुएशन में कहां पर इलेक्ट्रोनेगेटिविटी डिफरेंस ज्यादा होगा? कहां पर? सवाल सुन लीजिए अच्छी तरीके से. मेटल फिक्स है, से फॉर एग्जांपल सोडियम है. ओके और फ्लोरीन से आयोडीन जाएंगे तो इलेक्ट्रोनेगेटिविटी क्या हो रहा है? कम होते जा रहा है. तो बताइए दोस्तों कहां पर इलेक्ट्रोनेगेटिविटी का जो फासला है वो ज्यादा है? वेयर इट इज मोर. ओके आई होप यू हैव अंडरस्टूड द क्वेश्चन. अब मैं आपको ऑप्शंस भी देता हूं. MF, इज इट इन MF के इज इट इन MI? सवाल सबका समझ में आ गया होगा कि ये दो एक्सट्रीम केस ले रहा हूं मैं. आई एम टेकिंग द टू एक्सट्रीम केसेस. ओके सो प्लीज टेल मी. ओके MF, okay, and MI. Okay, these are the two extreme cases. Fluorine is most electronegative, iodine is least electronegative. तो इलेक्ट्रोनेगेटिविटी डिफरेंस सबसे ज्यादा कहां पर है? आप बता सकते हो मुझे? इज इट इन MF कि इज इट इन MI? I am waiting for your answers. Where it is going to be more? Electronegativity difference, where it is going to be more, and there are two options in front of you, MF and MI. Where is it going to be more? Suppose we take it as sodium. Okay, so sodium fluoride में इलेक्ट्रोनेगेटिव डिफरेंस ज्यादा होगा कि सोडियम आयोडाइड में इलेक्ट्रोनेगेटिव डिफरेंस ज्यादा होगा. कहां पर ज्यादा इलेक्ट्रोनेगेटिव डिफरेंस होगा? क्योंकि उसके हिसाब से वी आर गोइंग टू डिस्कस अबाउट द आयोनिक कैरेक्टर्स. सो प्लीज टेल मी वेयर इट इज गोइंग टू बी मोर. So, because fluorine is highly electronegative, so ionic character is going to be highest in case of MF, then goes for MCl, then goes for MBr, and then it goes for Mi. Okay, so this is what the order of electronegativity is, and this is the order of ionic character. Okay, so यहाँ पर we say the compounds are more ionic, and here we say the compounds are less ionic. Ionic character is more over here. यहां पर हम बोलेंगे ionic character is less, or we say the covalent character, I write down as CC, so the covalent character is going to be what? High. Okay, this is what we can conclude on the basis of electronegativity, because एक बात हमेशा याद रखिएगा, electronegativity difference जिसे हम लोग बोलते हैं as end. So electronegative difference is directly proportional to the ionic character, that is IC. Okay, उससे वो directly proportional है. So greater is the electronegative difference, greater is going to be the ionic character. Okay, so I hope you have understood up to this. If you want, you can take a screenshot, or there's no requirement also, because you can watch this video whenever you want to. Now we go into the next part, and that is, I give you some compounds such as SnCl4, and this is SnCl2. Okay, the other one I give you as PbCl4 and PbCl2. Okay, these are the two compounds, or probably if you cannot see it, I can just write it down on the other side. Okay, the compounds I'm writing is SnCl4, stannic chloride. This is stannous chloride. Similarly, you got tetrachloride PbCl4 and PbCl2. So if you try to compare this, then what is the answer is, chlorine will show always a charge of -1, all right, because it's more electronegative than tin as well as lead. All right, so because of -1 charge on every chlorine, tin has a charge of +4. यहाँ पर tin has a charge of +2. Similarly, lead has a charge of +4. यहाँ पर the lead has a charge of +2. Okay. Now, when the characters are being found out, okay, with respect to the covalent characters, so the observation is that the metal with a higher oxidation state, okay, tin and lead are metals because they are more electropositive as compared to chlorine, and the more electropositive species are basically called as metals. So the more electropositive, or we say the more charge on the metal, greater is the covalent character. Okay, greater the charge on the metal, greater will be the covalent character. So that means if I'm going to compare between SnCl4 and SnCl2, then I will say that the covalent character in SnCl4 is more. Similarly, PbCl4 and PbCl2, if I compare, then once again I say that यहाँ पे lead का charge +4 है, यहाँ पे lead का charge +2 है, so यहाँ पे covalent character उसका ज़्यादा है. Okay, so greater the charge on the metal, okay, when it combines with a halogen, okay, because we are right now talking about group number 17, all right. So greater the charge on that particular metal, so obviously we say the covalent character is more. The reason, if you want, and that is there's greater overlapping take place. Okay, more the charge, more is the overlapping, and overlapping results in a covalent bond. ये आप लोगों को मालूम है. You have done this in your lower classes, so that's the reason we say the covalent character is going to be what? More. All right. So this was about action with respect to what? Metals, as well as group 16 and group 17. When we talk about group 18, as usual, we have to say that for group 18, they are not directly going to combine with group 18 inert to metals. Okay, जैसे मैंने आप लोग को रिएक्शन बताया था विद रिस्पेक्ट टू ऑक्सीजन, मैंने बताया था विद रिस्पेक्ट टू हाइड्रोजन, मैंने बताया था. हाँ, हैलोजेंस के साथ के रिएक्शन में मैंने बोला था आप लोगों को कि xenon has the ability to combine with halogens because of the greater size, because of the ability of d orbitals, because his ionization enthalpy is low. तो ये सब reasons के वजह से xenon can have combined with halogens. ओके, वरना बाकी जिसके साथ भी मैंने आपको रिएक्शन बताया था, मैंने आपको ऑक्सीजन के साथ, हाइड्रोजन के साथ, मैंने ये मेटल्स के साथ, जहां पर भी मैंने रिएक्शन बताया तो आपको मैंने बता दिया था कि ग्रुप 18 एलिमेंट्स आर इनर्ट टू ऑल दीज स्पीशीज, दे डू नॉट डायरेक्टली रिएक्ट विद इट. तो यहां पर भी वही सेम स्टेटमेंट है, द ग्रुप 18 एलिमेंट्स आर इनर्ट टुवर्ड्स मेटल्स एंड देयरफॉर दे डू नॉट कंबाइन विद मेटल्स. ठीक है, सो दिस वाज ऑल अबाउट द रिएक्शन विद मेटल्स एंड आई होप यू हैव understood this very well. I hope everybody has understood this. If you want, you can put a comment whether you have understood or not. It's your choice. I'm not forcing you. So yes, that whether I need to once again explain this or I need to continue. इसलिए मैं आपको पूछता हूँ. लेकिन आपको इच्छा नहीं है कुछ कमेंट करने की, इट इज योर ऑप्शन. Okay, anyways, most of you doesn't seem to be interested. Anyways, I can't help it now for this. Okay, I'm giving my best. Okay, but then if you're not interested, what else I can do? Anyways, I will go into the next topic, and that is called as allotropy. Now, what is allotropy is? Okay, allotropy, you have heard about this word before as well. Okay, once again, I'll try to explain you that. Allotropy is related to what? Same element. Okay, ये आपको याद रखना है. Okay, हर एक कंसेप्ट के साथ एक टर्म याद रखोगे तो अपना पूरा मिल जाएगा आप लोग को. ओके, सब कुछ याद रखने की जरूरत नहीं है. एक पर्टिकुलर कैची वर्ड विच वी कॉल इट एज, यू नीड टू रिमेंबर दैट. सो अकॉर्डिंगली यू कम टू नो द एंटायर कंसेप्ट वेल. ओके, एंड व्हाट इज दैट कैची वर्ड इज सेम एलिमेंट. अब इतने सेम एलिमेंट ये वर्ड से आपको बहुत कुछ इंफॉर्मेशन मिल जाता है. There are so many informations you get, and that is what? Okay, I'll try to explain you that. See, if the element is going to be the same, so atomic number is going to be the same because element is related to atomic number. Sequences are. Okay, you need to just understand that linkage. Okay, so if the element is same, the atomic number is same. If the atomic number is same, that means the number of electrons are going to be same because they are related to that number of electrons. नंबर ऑफ इलेक्ट्रॉन्स आर रिलेटेड टू केमिकल प्रॉपर्टीज, क्योंकि केमिकल प्रॉपर्टीज की दोस्तों जब हम बात करते हैं तो केमिकल प्रॉपर्टीज आर ओनली टेकिंग प्लेस ड्यू टू स्पीशीज आउटसाइड द न्यूक्लियस. इनसाइड द न्यूक्लियस अगर कोई भी रिएक्शन हो रहा है देन आई कॉल इट एज अ न्यूक्लियर रिएक्शन, but this is taking place outside the nucleus and therefore we call it also as a chemical properties. और outside the nucleus आप सब लोग अच्छी तरीके से जानते हो कि only and only electrons are present and therefore electrons are responsible for the chemical properties. Okay, तो ये देखिए अब ये पूरा सीक्वेंस देखो आप, एलोट्रॉपी में सिर्फ इतना याद रखने का एलिमेंट सेम है. अब ये एलिमेंट से क्या जुड़ा हुआ? एटॉमिक नंबर. एटॉमिक नंबर इज रिलेटेड टू नंबर ऑफ इलेक्ट्रॉन्स. नंबर ऑफ इलेक्ट्रॉन्स आर रिलेटेड टू केमिकल प्रॉपर्टीज. So if I write down right in the beginning only that if element is same, then everything else is same. So we come to a conclusion that we are talking about those species where the chemical properties are same. Now always remember that there are two types of properties associated with a particular element. And what are those properties? Chemical properties and physical properties. So it's very obvious now that if the chemical properties are same, the physical properties has to be different. Okay, then only we can talk about more than one form. क्योंकि more than one है मतलब कहीं ना कहीं वहां पर कंपैरिजन आया है, और कंपैरिजन आता है दोस्तों तो एक बात हमेशा दिमाग में फिट कर दीजिए, और वो ये है कि डिफरेंस तो होगा, कोई ना कोई प्रकार का डिफरेंस होगा, सिमिलैरिटी भी होगा, डिफरेंस भी होगा. ओके, ये बात आपको दिमाग में फिट करके रखनी है. हमेशा सब कुछ सिमिलर नहीं होगा, हमेशा सब कुछ डिफरेंस भी नहीं होगा. इट्स अ मिक्सचर ऑफ ऑल. सो एलोट्रॉपी इज ऑलवेज रिलेटेड टू व्हाट? मोर देन वन फॉर्म्स. यू हैव लर्न दिस इन सॉलिड स्टेट आल्सो. इंट्रोडक्शन ऑफ द सॉलिड स्टेट में भी आपने पढ़ा है ये, अंडर पॉलीमॉर्फिज्म. Okay, that means an element is existing in more than one form. So obviously there has to be some sort of a difference as well. तो ये डिफरेंस क्या हो गया फिर? फिजिकल प्रॉपर्टीज का. तो ये आपको याद रखना है. सो एलोट्रॉपी, सेम एलिमेंट, सेम एटॉमिक नंबर, नंबर ऑफ इलेक्ट्रॉन सेम, एंड देयरफॉर केमिकल प्रॉपर्टीज सेम, एंड देयरफॉर वी से द फिजिकल प्रॉपर्टीज आर डिफरेंट, एंड दैट इज बेसिकली कॉल्ड एज एलोट्रॉपी. ऑलराइट, सो introduction part about what exactly allotropy is. I hope you have understood this. I just assume that you have understood because you don't give any responses, so I can't help it. So anyways, we go into the next part, and that is we are only going to talk about allotropy with respect to only and only group 16. Okay, in this particular syllabus. We are not going to talk about group 17 at all. Okay, in this particular chapter. क्योंकि मैं बार बार बोल रहा हूँ, I am just sticking to the board syllabus. Okay, and if you don't trust me, you can go through the books which you are having. Okay, I'm not teaching you anything extra. हाँ, explanation में दे रहा हूँ आप लोग को, ताकि वो जो लिखा है टेक्स्ट बुक में वो आपको समझ में आ जाए, लेकिन एक्स्ट्रा अननेसेसरी मैं आपको नहीं पढ़ाऊंगा. ओके, इस बात का ध्यान रखिएगा. सो when we talk about group 16, the very first element is oxygen. So when I talk about oxygen, we talk about there are two forms of oxygen. One is O2 and the other one is O3. Okay, देखो दोस्तों, generally what happens is the students बोलते फिर जब भी हम लोग ऑक्सीजन बोलते तो it is O2. Actually we just commonly call it as O2. Okay, अगर उसका केमिकल फॉर्मूला के हिसाब से अगर हमें जाना है then we have to call it as dioxygen. Okay, it is actually dioxygen. लेकिन क्या हो गया कि by default whenever we say oxygen that means we say it is O2. जब भी हम लोग नाइट्रोजन बोलते so we consider it as what? N2. Okay, but actually it is not like that. We need to call it as dinitrogen dioxygen. Oxygen means only a single element. Okay, and that is nothing but what? O. ऐसा लिखना है. Okay, लेकिन ये इसलिए हम लोग ने बोला है कि उसका जो दो फॉर्म्स है, that is O2 and O3. This is actually being called as, technically speaking, we call it as dioxygen. Okay, ये technical speaking है. And O3 तो आप जानते हो, it is ozone. Okay, this is with respect to oxygen. फिर दूसरा है सल्फर. सल्फर हैज गॉट वेराइटी ऑफ फॉर्म्स. ओके, बहुत सारे अलग अलग फॉर्म्स है उसके. उसमें से द टू मोस्ट प्रिडोमिनेंट, द मोस्ट इंपॉर्टेंट फॉर्म्स, ओके, एंड दे आर रोम्बिक सल्फर, जिसको हम अल्फा सल्फर के नाम से भी अच्छी तरीके से जानते हैं, and the other one is monoclinic sulfur, which is also called as beta sulfur. Okay, so ये हो गया for the second one, that is sulfur. Next is we go into selenium. Selenium also predominantly exists in two forms. It can be more than one forms also, but then we are going to show the predominant forms. Predominant मतलब क्या? The one which can exist in greater proportions. So selenium में there are going to be two forms. One is going to be a red form and the other one is a gray form. Okay, so it is based on color. Red वाला non-metallic है और gray वाला जो है वो metallic है. Okay, क्योंकि selenium is a metalloid. I've explained you this in my previous lectures that selenium is a metalloid, so it can show a metallic character as well as a non-metallic character. All right. Now, after selenium, we move on to the next form. Again, next element, and that is tellurium. Tellurium exists in two forms. One is a crystalline form, and the other one is amorphous. And you guys know it very well. You've done this in your chapter of solid state. What is crystalline and amorphous is all about. It is predominantly with reference to the arrangement. If the arrangement is going to be regular, okay, if there is a periodicity in the arrangement of the particles, then we call it as crystalline. And if it is random, so we call it as amorphous. All right. So this is about tellurium, crystalline as well as amorphous. And the last one is polonium. Polonium, I did say that it's going to be radioactive. Okay, it has an ability to emit radiations. लेकिन उसका दो फॉर्म एग्जिस्ट होता है. Okay, one is an alpha form and the other one is a beta form. Okay, it exists for a certain period of time. Okay, और आपको ये भी याद होगा when I was explaining you about the various characters, okay, the metallic and the non-metallic characters, तो उसमें मैंने आपको बताया था कि oxygen and sulfur are non-metals. Selenium and tellurium are metalloids. And polonium की जब हम बात करते हैं, so polonium is distinctly a metal. Okay, when I use this word distinctly a metal, इसका मतलब क्या हो जाता है कि yes, it is always going to show a metallic character. उसके बिना वो कोई और character दिखाएगा नहीं. Okay, so alpha and beta, both of them are going to be what? Metallic. Come on, please tell me, have you understood this? So this is allotropy with respect to group 16. I considered all the elements at the moment. Okay, and then we will be discussing slightly in detail with respect to sulfur, that is rhombic as well as monoclinic. उसका थोड़ा हम डिटेल में पढ़ाई करेंगे, लेकिन अभी जो आपके सामने जो मैंने आपको लिख के दिया है, that is with respect to the overall group 16. Group 17 तो नहीं है इस चैप्टर में, नहीं पढ़ना है उसको. ओके, हमें सिर्फ ग्रुप 16 पढ़ना है और उसके जो मेन फॉर्म्स है वही हमें पढ़ना है. ऑलराइट, और जो डिटेल में पढ़ाना है और वो मैं पढ़ाऊंगा. ओके, बिकॉज आई नो द सिलेबस वेरी वेल, सो दैट विल बी विद रिस्पेक्ट टू rhombic sulfur as well as monoclinic sulfur. I hope you have understood this very well. You can just have a look at it. जैसे मैंने पहले ही बोला है कि because this YouTube is a platform, so you need not take a screenshot also of this. You can listen to it whenever you want. Okay, this is the advantage of this platform. All right, so I guess you have gone through it, and we now move on to the next part. So we need to try to talk in slightly detailed part with respect to the allotropes of sulfur. Okay, so we have two forms of sulfur. The first one, we call it as rhombic sulfur, or we also call it as the alpha sulfur. Okay, one is rhombic sulfur. The other one we have is monoclinic sulfur, or we also call it as beta sulfur. Okay, there are various points on the basis of which we are going to discuss. The first one is we talk about with respect to what? Color. So color, यहां पर हमें बोलना है कि it is pale yellow. यहां पर हमें बोलना है कि it is going to be bright yellow. Okay, this is the first one. Okay, there will be some similarity and there will be differences. So यहाँ पे थोड़ा, both of them are yellow, but ये थोड़ा pale है, and this is going to be what? A brighter one. So that is the first point, and that is with respect to what? Color. Next is we go into the shape. Shape is orthorhombic. Okay, you probably know about this. It's a crystal system. Okay, that is orthorhombic. Okay, 7 crystal systems in solid state. You must have learned. So one of the crystal system is called as what? Orthorhombic. And these are needle shape. So they are very fine. They are needle shaped crystals. Okay, needle देखा होगा आपने, सुई धागा का जो सुई होता है, तो उसके जैसे वो crystals है उसके. Okay, next part we go into, and that is its melting point. Melting point may be, there is going to be only a slight variation, not a very high variation, and that is, I'll give you the value so that you can understand this very well. It is 385.8 Kelvin, and this is going to be 393 Kelvin. So hardly it's going to be around, say, to be more precise, 7.2 Kelvin का फर्क है. Okay, with respect to what? Melting point. A melting point के बाद, we go into the next part, and that is, we talk about density. This is 2.069 grams per cm cube, and this is going to be 1.989 grams per cm cube. So you can see once again the variation is not too much. All right, this is just slightly over 2, and this is just approaching 2. So it's a slight difference. So we can just say that slightly the rhombic sulfur is heavier as compared to what? Monoclinic sulfur. Solubility, it is similarity है इसमें. Okay, they are insoluble in water. Okay, water में it is insoluble. So what I do now is, to make you understand this, I put it the entire one like this. Okay, so it is applicable to both of them. I hope you understand this. You are very smart enough now. Okay, of this 21st generation, you are students, so you know this very well. So insoluble in water for both rhombic as well as monoclinic, and both of them are going to be soluble in carbon disulfide. Okay, so it's common. This property is common for both rhombic sulfur as well as monoclinic sulfur. Okay, next part is we go into its stability. Stability, we say below 369 Kelvin, it is stable. Okay, below 369 Kelvin, it is what? Stable. So what is going to happen above 369? That is also a question mark. Because we are stable, we are science students, so we need to know the answers to this. So above 369 Kelvin, it gets converted to a beta sulfur. Okay, so there is a transformation taking place from an alpha form to a beta form. It is also called as a phase transition. And that's why the 369 Kelvin is called as a transition temperature. Okay, उसे क्या बोला जाता है? Transition temperature. Similarly, इधर क्या होगा अभी समझ में आ गया होगा आपको. Once you understand this concept, this is also very easy, and that means they are going to be stable above 369 Kelvin. यानी इसका मतलब क्या हो गया कि below 369 Kelvin, it gets transferred, okay, into alpha sulfur. Okay, it gets transferred to what? Alpha sulfur. Okay, I hope you understood this part. Okay, next part is about the structure. ये shape था, अभी ये structure है. So once again, I do it in the center itself. So you understand what I mean by this? Yes. One, two, three, four, 5, 6, 7, 8. So S8 crown shaped structure. A reminder to all of you is, please try to see this video on a full screen. So structure is crown shaped. Okay, for both of them. So that's why I've written at the center. All right. So this was the point number 7. For point number 8, I'll just erase this and I'll write it down. So first of all, we just go through the 7 points. Okay, recap of 7 points. What are we discussing right now is the differences and similarity. Okay, so I use the word comparison. Okay, between the beta sulfur as well as a alpha sulfur. All right. So there will be some similarities and some differences. So we start with the first point, and that is color. So when we talk about color, there is a difference. Okay, in terms of the intensity. Okay, the color is the same, but the intensity is different. So pale yellow, bright yellow. You go into the shape part, it's orthorhombic, and for monoclinic, we have a needle shape crystal. For melting point, the difference is very less. It's 7.2 Kelvin is the difference. 385.8 is rhombic, and 393 is monoclinic. Density is slightly denser. Okay, alpha is slightly denser than the beta ones. The values are there in front of you, 2.069 and 1.989. Solubility, it's common for both of them. Both of them are insoluble in water. Both of them are soluble in carbon disulfide. Stability, 369 Kelvin. This is what the temperature you need to remember. Okay, below 369, it's the alpha sulfur is going to be stable. And above 369 is the beta sulfur is going to be stable. And then vice versa you do it. If below it is stable, so above it will be converted to beta sulfur. And यहाँ पर अगर वो above 369 पे stable है तो below पे हो क्या हो जाएगा, convert हो जाएगा into alpha sulfur. And when you talk about the structure, it's a crown shaped structure. आप देख सकते हो total there are going to be 8 sulfur atoms which are being bonded with each other, and it resembles like a crown. And that's why we call it as a crown shaped structure. All right, so I hope you have understood up to this 7 points. 1 point baki hai preparation ka, but then once I just erase this and then I write it down so that it is very clearly visible to all of you. Okay, visibility will not be a problem. So I hope everyone has understood all the 7 points of comparison. Please have a look at it, and if you wish, you can comment whether you have understood or not. All right, so I'll just explain you the last part, and that is about the preparation. There's a slight variation as far as the preparation is being concerned. Okay, and that is, if you talk about, as I said, the point is preparation. The powdered sulfur, actually the sulfur rolls are available. So rolled sulfur has to be powdered. It has to be taken with carbon disulfide. Okay, it becomes soluble, as I already said, and then you heat it, okay, till the carbon disulfide gets evaporated. So there is evaporation taking place, and you cool it, you get pale yellow orthorhombic crystals of alpha sulfur. Okay, once again I repeat, the rolls of sulfur are available. You powder it, and then you take it along with carbon disulfide. You get a solution form, because in the previous point only I told you that both alpha and beta are going to be soluble in carbon disulfide. So I dissolve it in carbon disulfide and I do the evaporation. So the solute will remain as it is. The solvent will volatilize off. I cool it, okay, and I get pale yellow alpha sulfur orthorhombic crystals. All right. I hope this is being clear to all of you. Monoclinic sulfur, what we do is, we take a rhombic sulfur. Once again, we take it in an evaporating dish along with water as well as carbon disulfide together. And then what we do is we heat it and then we cool it. On cooling, we get a needle-shaped crystals. Whatever the liquid is there, okay, on cooling, the liquid is being removed. and we get the needle-shaped crystals. So this is obtained from rhombic sulfur. So you take it in a dish, you heat it, add some water, okay, and because it is insoluble, so you can mix it with some carbon disulfide also. So here it is only carbon disulfide, but there it is be carbon disulfide as well as water both, and then you cool it. Whatever the liquid which is there, okay, that can be removed, and on removing the liquid and on cooling, we get needle-shaped crystals of monoclinic sulfur. So I hope you have understood up to this. So with this, we come to an end of the topic of allotropy. Okay, because we are considering all particular sections out here. So allotropy concept is done, whereby what we have discussed about allotropy is, first of all, with respect to group 16 elements, group 17 elements not to be discussed. So forget about it. Okay, next. Group 16, first of all, from oxygen to polonium, I told you what are the prominent forms of these elements. And once that was being done, and then we discussed slightly in detail with respect to the rhombic sulfur as well as monoclinic sulfur with respect to its comparison. All right. So this is what we talk about with respect to the allotropy part. All right. So I discussed 2 points today so far in this particular lecture. If you can recollect, the first point was about reaction with metals. Okay, where group 16 reacts with metals, group 17 reacts with metals, group 18 as usual inert. Okay, and then I spoke about allotropy. So I assume that so far everything is being clear. And then what I do is the last topic for today's lecture, and that is going to be oxoacids of sulfur. Okay, that I'll be discussing with you. Of course, there is oxoacids of halogens as well, but then that cannot be discussed in today's lecture because we'll be running out of time. So today's lecture, I'll just discuss about oxoacids of sulfur, and then we can stop. I presume that up till now, whatever I've discussed is being clear to all of you all. So the topic for today to be learned, and that is oxoacids, and that is of sulfur that we are going to consider. So as the name suggests, it is oxoacid. In inorganic chemistry, acidity is because of H, hydrogen. So whenever I talk about a substance, it's going to be acidic, so it is having a H over there. Okay, generally what we talk about in that respect. Okay, there has to be somewhere or the other H. Either it is not actually H, then what we do is we dissolve it in water and then we decide whether it is an acidic or basic. So in water, there is going to be H. Okay, so general concept is that in inorganic chemistry, we talk about acid with respect to H. Oxo is nothing but oxygen. All right, and then we have what? Sulfur. So we are talking about, my dear friends, those compounds where there are going to be 3 elements. Okay, which are those 3 elements? First one is oxygen, the second one is going to be hydrogen, and the third one is going to be sulfur. इनके ऑक्सो एसिड और सल्फर हम लोग कंसीडर करने वाले हैं, तो इसलिए हमारे पास 3 एलिमेंट्स होना चाहिए ये कंपाउंड में, ऑक्सीजन, हाइड्रोजन एज वेल एज सल्फर, एंड दे विल बी इन वेरियस proportions. Okay, and therefore we have got various compounds that needs to be learned under this particular topic of oxoacids. Okay, so I hope you have understood up to this. Next point is कि जब भी कंपाउंड में एक से ज्यादा एलिमेंट्स है तो सीक्वेंस कैसा होता है. Okay, how to write down the sequence? That means यहाँ पर भी मैंने बोला आप लोगों को कि these compounds are going to contain 3 elements: hydrogen, oxygen, and sulfur. So which will be the sequence? Who's going to come first? Who's going to come second? Who's going to come third? Okay, ये कैसे डिसाइड करना है? So and that is I give you a very simple logic, and that is, of course, there are exceptional cases every time because chemistry is such a large concept, it's a large subject, so there will be some exceptional cases, but forget about it. हम जनरल केसेस कंसिडर करेंगे, और जनरल केसेस में ऐसा है दोस्तों कि जब भी हमारे पास कंपाउंड है, इनऑर्गेनिक कंपाउंड्स, और जहां पर इनऑर्गेनिक की बात कर रहा हूं दोस्तों, ओके, आई एम नॉट टॉकिंग अबाउट ऑर्गेनिक कंपाउंड्स. सो इनऑर्गेनिक कंपाउंड्स की जब हम बात करते हैं और जहां पर एक से ज्यादा एलिमेंट मौजूद है, यस, सो इनऑर्गेनिक कंपाउंड्स के जहां पर एक से ज्यादा एलिमेंट्स मौजूद है, ऑलराइट, तो फिर क्या करना है, हमें लिखना है उनका ऑर्डर जो है, दैट इज अकॉर्डिंग टू इलेक्ट्रोनेगेटिविटी. ओके, इंक्रीजिंग ऑर्डर ऑफ इलेक्ट्रोनेगेटिविटी. ओके, वो याद रखो आप, डोंट फॉरगेट दिस. ओके, इट इज वंस अगेन आई राइट इट डाउन ओवर हियर सो दैट आपको समझेगा. पहले मैं आपको बताता हूं, ऑक्सोएसिड्स ऑफ सल्फर मतलब हाइड्रोजन होना चाहिए, ऑक्सीजन होना चाहिए, सल्फर होना चाहिए. ओके, नाउ राइटिंग हैज टू बी डन इन द इंक्रीजिंग ऑर्डर ऑफ इलेक्ट्रोनेगेटिविटी. ओके, अब आपको वैल्यूज चाहिए, मैं आपको वैल्यूज भी देता हूं. हाइड्रोजन का इलेक्ट्रोनेगेटिविटी वैल्यू इज 2.1, सल्फर का 2.5 और ऑक्सीजन इज 3.5. 2.1 इज हाइड्रोजन, फिर कौन आएगा, सल्फर, कितना है 2.5, और फिर कौन आएगा, ऑक्सीजन, दैट इज व्हाट 3.5. यानी द ऑर्डर विल बी फर्स्ट कम्स हाइड्रोजन, उसके बाद आएगा सल्फर और उसके बाद आएगा ऑक्सीजन. दिस इज द सीक्वेंस of the elements. Proportion will go on changing. Okay, it can be 2, 3, 4, and 5. That way it can be. Okay, so that we are going to discuss later on. ठीक है? So increasing order of electronegativity, H, S, and O. Okay, that is what we are going to consider. तो सबसे पहले है, and that is called as sulfurous acid. Okay, we talk about what? Sulfurous acid. So sulfurous acid का मैं आपको बताना चाहूंगा स्ट्रक्चरल फॉर्मूला. ओके, HOS double bond OH. Okay, this is a structural formula. You know what is a structural formula is? Structural formula say you understand that which element is going to be connected with which element and with how many bonds. This is the information you get when you go for structural formula. Alright, so in this particular case it is HOS double bond OH. तो ये आपको समझ में आता है कि this is for the entire linkages. और फिर क्या करना है आपको कि from the structural formula you go for the molecular formula. Molecular formula में क्या पता चलता है हमें? Two things. Which are the elements present and what is the proportion of those elements, or what are the number of elements okay being present. ये हमें पता चलता है. This is from molecular formula. Those elements are being bonded with which other element through how many bonds, वो structural formula से पता चलता है. तो इस तरीके से दोस्तों दो फॉर्मूला है, structural formula as well as molecular formula. Okay, so I hope you are being very clear with this. तो ये structural formula के, अभी हम लोग molecular formula पे जाएंगे. मैंने आपको ऑलरेडी बोला HSO, ये सीक्वेंस फॉलो करना, इंक्रीजिंग ऑर्डर ऑफ इलेक्ट्रोनेगेटिविटी. H कितना है 2, तो यहाँ पे मैं 2 लिखता हूं. ओके, सल्फर एक ही है, ऑक्सीजन कितना है 3, तो 3, सो H2SO3, ये हो गया इसका मॉलिक्यूलर फॉर्मूला. तो what I want you to understand over here, please, and that is because that is going to be important for somewhere or the other when you go for your entrance exams. All right, so from the molecular formula, मतलब गौर से देखो, ये इसमें से ये नहीं पता कर सकते, we cannot find out, okay, because this is experimental. So merely by looking at the formula, it is very difficult to predict its structural formula. But from the structural formula, you can find out the molecular formula. Okay, ये हम लोग कर सकते हैं. Okay, इसलिए मैंने आपको ये अलग अलग बता दिया ताकि आपको ये कंसेप्ट क्लियर हो जाए दिमाग में कि yes, कि this is what is called as a structural formula, this is a molecular formula, and from the structural formula we can find out the molecular formula. Okay, so this is sulfurous acid. अभी हम जाएंगे सल्फ्यूरिक एसिड में. सल्फ्यूरिक एसिड में क्या करो, एक ऑक्सीजन ऐड कर दो. You have to add an oxygen to this. अभी addition always takes place to the central atom. तो ये कौन सा है central? इसको कौन है? Sulfur है. So you get HOSOH double bond oxygen. It's already there. और फिर ऑक्सीजन ऐड करना है. ऑक्सीजन यू नो इट इज डबली बॉन्डेड, बाईवैलेंट उसका वैलेंस ही है. तो ये आ गया. फॉर्मूला तो आपको मालूम ही है. फिर इट इज H2SO4. ओके, तो ये हो गया सल्फ्यूरिक एसिड. ओके, नेक्स्ट वन इज वी गो इनटू डाइसल्फ्यूरिक एसिड. Okay, so in a disulfuric acid, what we do is, sulfuric acid है तो याद रखने का तरीका बताता हूँ. Okay, so that I don't want you to by heart all these concepts. Okay, ये सब by heart नहीं करने का, इसलिए मैं आपको ये इस सीक्वेंस में बता रहा हूँ. Disulfuric acid में क्या करो कि this is sulfuric acid, so obviously it will have a tendency to lose H. Okay, so you lose that H and this entire unit. Okay, I show you by a different color. ये जो यूनिट है, ओके, ये H हटाने के बाद O के साथ जोड़ दो. ओके, यानी in other words what you do is remove this H and flip it like this. तो आपको डाइसल्फ्यूरिक एसिड मिलेगा. डाई मतलब it is 2. तो देखो क्या आएगा फिर. एज यूजुअल पहले तो लिखो HOS डबल बॉन्ड O. अभी इसको फ्लिप करो तो क्या आएगा? S डबल बॉन्ड O OH. ओके, दिस इज डाइसल्फ्यूरिक एसिड. Alright, now the formula for this is कितना H है? 2. S कितना है? 2. ऑक्सीजन कितना है? 1 2 3 4 5 6 7. H2O7. बोलो, समझ में आया यहां तक? Next one is we go into peroxy. Okay, we go into a peroxy sulfuric acid, or else because the visibility has to be there. So I think every one of you have understood up to this. These three are very clear. All these three are very clear to all of you. Okay, so I'll just erase this off so I get a greater space for you all to see. We're going to number 4, peroxy monosulfuric acid. मोनो मीन्स 1. पेरोक्सी मतलब ऑक्सीजन अटैच टू ऑक्सीजन. तो देखो अभी याद कैसे करने का उसको बताता हूं. HOS double bond O OH. This was sulfuric acid. All right, everybody knows about this. What I do now is it's mono only, so this is one only. All right, now I want a peroxy group. So on any one of the side, either on the left hand side or on the right hand side, what you do is you add an oxygen to a oxygen. Don't add it to sulfur or something like that, okay, please. Okay, you are either to this oxygen or to this oxygen, okay, because they are attached to hydrogen. Okay, so either to the underlying left oxygen or the underlying right oxygen, you add an oxygen. All right, so we get, suppose I add it to the right hand side this way. So this becomes a peroxide linkage. Okay, ये क्या बन जाता है? पेरोक्साइड लिंकेज. जो मैं आपको बता रहा था when I was talking about oxidation state. पेरोक्साइड लिंकेज में ऑक्सीजन का चार्ज होता है -1 ये ऑक्साइड लिंकेज है तो -2. ओके, सो दिस इज पेरोक्सी मोनोसल्फ्यूरिक एसिड. तो फॉर्मूला तो आपको मालूम है, सल्फ्यूरिक एसिड यू नो द फॉर्मूला H2SO4. तो एक ऑक्सीजन ऐड किया हम लोग ने, सो वी गेट H2SO5. So this is peroxy monosulfuric acid, which is the number 4 acid. Have you all understood this? How to find out the peroxy monosulfuric acid? Okay, now we go into number 5. Peroxy disulfuric acid. देखो वापस से सल्फ्यूरिक एसिड याद रखो, HOS डबल बॉन्ड O एंड OH। ओके, ये H2SO4 है, बराबर है। अब क्या करना है, देखो देयर हैज टू बी अ पेरोक्सी लिंकेज एंड इट इज अ डाइसल्फ्यूरिक एसिड, मतलब 2 टाइम्स है। ओके, तो क्या करने का है, एक H हटा दो, और फिर मैंने बोला था, अगर आपको याद है, इन द डाइसल्फ्यूरिक एसिड कि वी हैव फ्लिप्ड इट दिस वे। अब क्या करो मालूम है, यू डू द एंटायर फ्लिपिंग फ्रॉम हियर, यानी इमेजिन, मैं आपको और क्लियर करके बताता हूं, इमेजिन दैट देयर इज अ मिरर ओवर हियर। ओके, तो अगर इधर मिरर है तो इसका पूरा मिरर इमेज इधर आएगा, सो ये ऑक्सीजन के बाजू में दूसरा ऑक्सीजन आ जाएगा, तो पेरोक्सी बन जाएगा। ओके, सो यू ड्रॉ द स्ट्रक्चर ऑफ सल्फ्यूरिक एसिड, H हटा दो and then take the mirror image. That way you need to remember. So what we get is OS double bond O OH. ये मिल गया आपको। Okay, and this is the underlying oxygen are the peroxy oxygens. So उसका molecular formula H कितना है, 2 H2, सल्फर 2, ऑक्सीजन देखो 1 2 3 4 5 6 7 8, H2SO8। ओके, ये बन गया हमारा पेरोक्सी डाइसल्फ्यूरिक एसिड। यानी हर बार मैं आपको सल्फ्यूरिक एसिड से ही दूसरे एसिड बनाने की बता रहा हूं, ताकि इट बिकम्स वेरी इजी फॉर यू टू अंडरस्टैंड। एंड द लास्ट वन वी गो फॉर, एंड दैट इज थायोसल्फ्यूरिक एसिड। द लास्ट वन इज थायोसल्फ्यूरिक एसिड। Okay, now for thiosulfuric acid, once again what are we going to do is, sulfuric acid पे जाते हैं वापस, HOS डबल बॉन्ड O OH। अब क्या करना है, यहाँ पे थायो है, थायो मीन्स what, sulfur। So what you do is either on the top or on the left, sorry, top or bottom, you replace the oxygen by sulfur। तो में से कोई भी एक ऑक्सीजन को सल्फर से रिप्लेस करो, तो मैं इससे कर देता हूं, टॉप वाले से कर देता हूं। ओके, तो ये मिल गया आपने को। ओके, दिस इज थायोसल्फ्यूरिक एसिड। तो फार्मूला क्या हो जाएगा, H2SO4 था, तो अभी वो बन जाएगा H2, ऐसा ही है, एक सल्फर बड़ा और एक ऑक्सीजन कम हुआ है, सो H2S2 एंड ऑक्सीजन नाउ बिकम्स 3, सो H2S2O3। तो ये बन गया अपना थायोसल्फ्यूरिक एसिड। Okay, so these are the 6 types of acids which are there in your syllabus. You are lucky enough that you are going to appear for this particular syllabus. The reason is because last year in this syllabus there were 12 oxyacids. Okay, that was to be learned. All right, if you don't trust me, okay, you can go through, if anybody is having that particular book, okay, the textbook of last year, you just go through it. Okay, and you will come to know. But this time it's very lucky that you got only 6 of them. So first is sulfurous acid, HOS ऊपर डबल बॉन्ड ऑक्सीजन, राइट में OH, फिर उसको एक ऑक्सीजन ऐड कर दो, यू गेट सल्फ्यूरिक एसिड। सल्फ्यूरिक एसिड के बाद अलग अलग एसिड्स मिलता है, दैट इज डाइसल्फ्यूरिक एसिड। सो यू रिमूव H, ओके, कीप O एज इट इज एंड फ्लिप। ओके, अभी विदाउट O फ्लिप करना है तो हमें पेरोक्सी डाइसल्फ्यूरिक एसिड मिलेगा। सल्फ्यूरिक एसिड में एक O ऐड करो टू अनदर O, सो यू गेट अ मोनोसल्फ्यूरिक एसिड। और सल्फ्यूरिक एसिड में एक डबल बॉन्डेड O को रिप्लेस करो बाय S, तो आपको मिलेगा थायोसल्फ्यूरिक एसिड। तो दिस इज द वे यू नीड टू अंडरस्टैंड। ओके, टेक्स्ट बुक्स में यू दिस ऑल दीस ट्रिक्स विल नॉट बी गिवन टू यू। Okay, directly they will be giving you the formulas and you need to remember, that's it. But this is the trick you need to remember. From sulfuric acid, you can come for the disulfuric acid, for peroxy monosulfuric acid, for peroxy disulfuric acid, and for thiosulfuric acid. Okay, all these acids you can learn from sulfuric acid. यानी अगर एक मालूम है तो दूसरा फिर उसी, तो आपको बाकी के 4 मिल जाएंगे। ओके, तो टोटल आपको 6 ही पढ़ना है, सल्फ्यूरस सल्फ्यूरिक, और ये 4 मिलेंगे आपको। All right, so I hope you have understood the oxoacids of sulfur very well. Okay, is it very clear to everyone? Whatever concept I've explained you today in this lecture, is that all clear to every one of you all? Thanks for joining me. I'll see you next time. Till then, take care. Bye bye.